Today we're going to talk about the logical relations among the categorical forms. In the end, we'll also be introducing the notion of contradictories. Here we have two possible terms, and we're going to decide that the subject term is going to be dogs, and the predicate term is going to be fierce. But fierce by itself can be a categorical term because it's an adjective. So if you remember, terms have to be nouns. So we have to add some sort of a noun, complementary noun, which can be a very general, such as thing, being. In this case, let's make it animals. Now, with these two terms, let's build an I preposition and an O preposition. The result is, some dogs are fierce, and some dogs are not fierce. And really, remember that what we should write there is some dogs are fierce animals, and some dogs are not fierce animals. So if I ask you to render a given preposition in categorical term, you would have to add, to be strict, you have to add fierce animals, fierce things, something like that. Now, the question is, do I and O exclude each other? I mean, could both be true at the same time? So there are cases in which prepositions exclude each other, in cases that if one is true, the other cannot be true. For instance, suppose that I tell you on the one side that there is water in this bottle, and on the other side that there isn't hydrogen in the universe. Well, you see that both propositions exclude each other, because if one is true, then the other one cannot be true, right? And so is it the case here that both I and O exclude each other? And remember that this is just like asking, can both be true at the same time? The way to answer this question, or at least one way, is to see if we can build one Venn diagram which makes both propositions true at the same time. But let's begin by drawing the Venn diagrams corresponding to each of the propositions. So the first one is some S are P, and that is represented with an asterisk at the intersection between S or P, right? So there is at least one thing that is both S and P. And some S are not P, right? Well, we put an asterisk on the area of S that is outside of P. To make it into an example, let's take two dogs, Cuddles and Destroyer. And suppose that they weren't named ironically, right? So one of them is fierce, the other isn't. So which is which? Okay, supposing that Destroyer is an accurate name, right? Where would you put Destroyer in this Venn diagram? Area 1, 2, or 3? Well, it looks like Destroyer is both a dog and is fierce, right? So here's the intersection of the categories of dog and fierce, right? What we called area 2. So now, which proposition is made true by this diagram? Some dogs are fierce, or some dogs are not fierce? Clearly, it is a proposition with the I form. Some dogs are fierce. And the dog in question, of course, the one that makes it true, is Destroyer. Now, where would you place Cuddles? Again, and assuming that the name is apt, we place him in the area of those things that are dogs but are not fierce, right? And that is area 1. Same question as before. Which proposition is made true by this diagram? Is it some dogs are fierce or some dogs are not fierce? And again, the answer is clear. It is a proposition of the O form. That is, some dogs are not fierce. Now, suppose that we superimpose the two Venn diagrams and we get this composite Venn diagram. And so, which of these propositions is true in the depicted situation? Is it some dogs are fierce? Is it some dogs are not fierce? Is it neither of them or both of them? It is both of them. Proposition I is made true by the asterisk and area 2, right, where we place Destroyer. And proposition O is made true by the asterisk we place on area 1, right, where we have Cuddles. Now, back to our initial question. Do I and O exclude each other? That is, can both be true at the same time? Well, they don't exclude each other, right? They can be true at the same time because we can perfectly well conceive of a possible scenario in which both are true at the same time. And that possible scenario is represented by the Venn diagram in which both propositions are made true. Now, the same question, but with respect to A and I. Again, the A form is universal affirmative, as all S are P. And then doing the substitutions, we have all dogs are fierce. And this is represented by shading area 1, right? Namely, the area of those dogs that are not fierce, right? That means that there isn't a thing that is both a dog and is not fierce. Now to the right we have some dogs are fierce. And again, well, you see that just represented by putting an asterisk in the intersection of both sets. So we can see that we can superimpose both diagrams to create one single diagram that makes both sentences true. That is, the one with the form A, all dogs are fierce, and the one with the form I, some dogs are fierce. That means that both propositions are compatible, right? They can be true at the same time. They do not exclude each other. Now, the case of A and O is more interesting. So we have A, universal affirmative, which gives all dogs are fierce. We also have O, which is particular negative, which yields some dogs are not fierce. Now, could these be true at the same time? Well, intuitively not, right? If all dogs are fierce, that means that there isn't even one dog that is not fierce, right? So if A is true, O has to be false. And the same happens the other way around. If some dogs are not fierce, then it's not true that all dogs are fierce. So let's see how this is reflected with Venn diagrams. Proposition A is represented by shading area 1. That is, by indicating that area 1 is empty. On the other hand, proposition I is indicated by adding an asterisk to area 1, to the same area. And here we are indicating then that that area is not empty. Now, when we try to combine them into a single diagram, the combination is impossible because this is a diagram that in effect is saying both that area 1 is empty and also that area 1 is not empty. And that is, of course, an impossible state of affairs, an impossible situation. So this confirms our initial intuition that forms A and O of the same sentence indeed cannot be true at the same time. They exclude each other. If one is true, the other is false. And we show this by the impossibility of making a single diagram that makes both sentences true. Also notice that for any proposition, it is always the case that either its A form is true or the O form is true, right? So if I say that all dogs, it is either the case that all dogs are fierce or it is the case that at least one dog is not fierce, right? One of them has to be true. Of course, not both at the same time, but one of them, and exactly one. Thus, form A and O are contradictories. That is, they cannot be true at the same time, and always one and exactly one of them must be true. Which other pair of categorical forms is formed by contradictories? Forms E and I are also contradictories. So if you have no dog is fierce, which is E, and then you have also some dogs are fierce, which is I, well, you can't combine them into a single diagram, right? Because to make E true, we have to say that the intersection of the two sets, that is area 2, is empty. But to make I true, we have to say that the same area is not empty, right? So the requirements for making each of them a true, right, are incompatible. So they are both contradictories. And also it is the case that one and exactly one of them must be true. Okay, so this is an important concept, the concept of contradictory categorical forms.